because you're divided by 8, that's an exact number, 3 decimals, so I left it at exactly 3. Mean for y was 111.5. Okay? So that's the information top. Middle question is, what are the slope, y-intercept? The slope sets up as slope uses that equation. You'll be given that equation on the exam. Right? When you plug in the numbers, plug in the 2715.3 minus the 24.2 times the 111.5 divided by 8 divided by 20. Oops, wrong. Divided by squared. That's where the numbers all plug in. Yes? Mm-hmm. When you do all the math of that, I'm not going to go through it step by step, but all the math of that, when you calculate it out, it turns out to be about 12.00. If you got 12.01, that's okay. If you got 11.99, that's okay. How you round it, but you come out right at about 12. Mm-hmm. Right? That's the value for slope. Right? If you take your regression equation line, you plug in the slope here. You want to solve for A, you need the most representative values for X and most representative values for Y, which in this case are the means. So you plug in the mean values, which I have over there. So the mean value for Y is 111.5 times the mean value for X. Solve for A. A then will equal 75.
75.2.
25.2. Okay? So the next problem is, what's the regression line? Once you've got the slope, once you got the intercept, the full regression line becomes y equals 12x plus 75.2. And this is the actual regression line with best fit. Right?
What is the other term for that? Like, are you going to ask that on the test?
Line of best fit, regression line. I think it's sometimes called least squares regression line.
But you won't use that.
I'll typically use line of best fit or regression, linear regression.
Or linear regression.
It's pretty distinct from correlation coefficient. It's pretty distinct from z-score.
Yeah.
So the bottom four
So
questions
we
on the page
can't
are,
like take that as a note right now for the test.
you should have no difficulty recognizing the term linear or line.
Yeah.
Right? Least squares regression equation. It's all good. Bottom four is if you find somebody with a GPA of 1, what do you pick up? IQB, GPA of 2. You start plugging in values for X. Right? When you plug in a 1, so if X equals 1, Y then will equal 87.2. If X is equal to 2, Y equals 99.2. If X is equal to 3, Y equals 111.2. And if X equals 4, Y equals 123.2. Right? I didn't ask it, but I didn't ask the homework. If X equals 0, right, what do you predict IQ to be?
75.2.
75.2, right? Huh? Well, that's okay. That's the correct answer, right?
Mm-hmm.
So according to that equation, can you have an IQ score less than 75?
No.
Not for the equation.
Yeah, but for the
Are there
equation,
people in the
but
world
yeah.
who have IQs less than 75?
Yes.
Right? How can people in the world have IQs less than 75 if the equation predicts they can't?
Because we just have a sample set of scores.
And
Based on a limited GPA, like you only have from 0 to 4.
Close.
Okay. The range of scores in the IQ.
The equation assumes a straight line.
Exactly.
Right? The actual relationship between GPA and IQ may not be linear.
Yes, you're right.
You're so right.
You're assuming a single straight line. The single straight line may not be representative of the actual relationship in the world.
Right.
It might be curvilinear.
Yep.
Okay? But this can't deal with curvilinear stuff because it doesn't have a square term in it. So that's the first page. Any questions on the first page?
Nope.
Alright, so let me get rid of some things, but leave a couple things. Top of the next page is using the same data from the first one, calculate the degree of association between GPA. If I say degree of association, I can also say calculate the correlation between GPA and IQ. So either degree of association or correlation. Right? The distinction is, there's a little difference there. There are more than one way to calculate correlation coefficients, but all of them are still calculating degrees of association.
Meaning what you said.
If I say calculate the association, right, there may be more than one way to do it. So far, because of the interest of time, we missed a couple classes. I only gave you one way to do it, but keep in mind there are more ways to do it.
Oh, okay. You were just telling us. Oh, yeah.
So if I say correlation coefficient, that might be a Pearson product, or correlation coefficient R. If I use a little R, I'm talking about the Pearson product. That's what I'm using here. So
Okay.
calculate R.
Gotcha.
The formula for R, similar to the slope, but not quite.
And you're gonna put that formula on the test, right?
Huh?
Yep.
No, you haven't memorized this.
What?
I'm kidding. I'm kidding.
I'm
This
forfeiting the
formula
test
will-
now.
I will mention, I don't think I mentioned before, I will mention, this formula is sometimes represented in a different way in different textbooks.
Yeah.
Sometimes they
it had
collapse it in different
N
ways.
and, like, it had all type of weird stuff. I had to close that book. It was.
Close that.
It did. I closed the book too
Some
and
books
watched my
will write this
videos.
formula in a different way, depending on how you want to set up the numerator and denominator. The calculation is the same, but you can algebraically move this around a little bit. Right?
Alright.
So this is the correlation coefficient R. Notice the similarity between this and this. Effectively, the correlation coefficient R, right, is mathematically, you don't have to do this because it's implicit in the formula. It's effectively the slope of the z-scores from your x and your y variables over here. If you convert all your x scores and all your y scores into z-scores, and then do a slope equation on the z-scores, that's essentially this. Right? It's basically the correlation amongst the z-scores, or slope of the z-scores, which means the a term, the intercept term, drops off because it's always going to be 0, because the mean of your z-scores for x and the mean of the z-scores for y are always going to be 0 and 0, because that's the center of the z-distribution for y and the center of the z-distribution for x. Right? And the other thing to note for this particular separate, it'll be different on the exam, but for homework, you've already done this here, and you've already done this here, so I just plug in the exact same thing. Maybe move this out of the way so it'll be it. You've already done that, and that goes numerator, half the denominator. So I have to put the radical sign here. There's going to be a radical sign over all this. The only thing you need to plug in are the values for y here, which you got up here, right? The 1,0,0,912 minus the 1,115 over 8 squared. Right? So you already done 2/3 of this equation. Right? You already worked through the math from the previous problem. All I do is solve this part of the problem.
Question.
Right?
So for the 1.5, should it be 892
Yep, you're right.
instead?
Yeah.
I'm just looking at that on my page going, that's wrong. Yep, you're right.
We're gonna
There,
document
892.
your answer sheet.
Correct. Right. When you calculate the correlation coefficient, it's the correlation coefficient of delta.
You know
That's
something?
that nervous tinkle.
So, you did that on purpose. The square root.
I did not.
With the square
What, I
root.
put in all these numbers and did that one number over there? I think so. It's just a
I
happy
don't know, you
coincidence.
seem, I don't know, it seems like you would spend your time doing that.
It's
Like,
just a happy coincidence.
okay, if you say so.
Go ahead.
Why I get confused on like when to stop square rooting the bottom number?
You want to have
I mean, I did it on the homework because it just didn't, you know.
that portion is the sum of squares for x. This portion is the sum of squares for y. You have a sum of squares times a sum of squares. So effectively, that's a sum of squares, squared, that times that. If it were the exact same word, somebody should have x squared, somebody should have x squared here. That would be squared. You need to break it down to the right units. You get rid of that, raising the radical sign. Right? Take square root of the square number, and that pulls into the correct units.
Whenever you get a number, like
I feel like you just said explain it in a total different way.
When you get here, that's when I'm scared.
Once you get the full number after multiplying it in the denominator,
you did it all right.
you take square root. As a small hint for this, I can't say anybody's going to do this, but sometimes this has been done as a mistake. If you don't take the square root of it here, the number you get when you multiply these two sum of squares will be huge. It'll be a big number.
Yeah.
Right? Which means your correlation coefficient will come in to be something like 0.02 or 0.03 or 0.0111 something, right? And it'll be really, really, really close to 0. And if you actually suspect there's really a relationship, in this case, 0.66, which is reasonably strong with only 8 scores in it,
Right.
paired sets of scores, getting a correlation coefficient of near 0 is probably wrong. So you probably forgot a square root in it somewhere. Right? If your denominator seems extraordinarily large, which makes your overall R value extraordinarily close to 0, you might be suspicious. The problem is there, it's still in the ballpark of possibility.
Okay.
It's entirely possible you might have a correlation coefficient near 0. But if you get one near 0, you might double check and look at your math to make sure you took that square root. Otherwise, it might be larger than you think it is.
Okay. And then, so for the you know, I was looking around the book and was trying to figure out what you were gonna be multiple choice questioning this on. You follow me?
Do you have any specific questions? Because there are like 15 multiple choice questions.
Oh my goodness, man.
They should be pretty straightforward.
So that's what I was gonna.
And they're basically blocked into, there are questions about z-scores, there are questions about linear regressions, there are questions about correlation coefficients.
Okay.
And so, like, what understanding do we need to have? I found the inflection point. I found my notes on that. I remembered that it's just when it changes.
Mean of the z-score, area under the curve,
Okay.
asymptotic, right? Symmetrical, right?
What's that one?
Symmetrical,
No.
That's a
asymptotic.
practice when you
Means
switch.
Those the end never touches.
Oh.
Tails off infinitely in both directions.
Glad you told me that. I didn't know that.
Exactly. Okay. And then, like,
If you have a curve
look at his
that
face.
approaches a line, but never actually touches that line,
That's ace.
that's asymptotic.
Asymptotic. It's asymptotic. Asymptotic.
Oh, weak.
Okay, which is the one when it
Okay.
flipped?
And then, so if you're asking us a question about inflection point, it's just when it goes like
When it
plus
changes
one
direction.
standard deviation.
In the curve it goes there.
Right.
That happens to occur at +1, -1 standard deviation, or z-scores, above and below the mean.
Do you do the and like I said, the book, I got a lot of more information I feel than what I needed.
Hopefully,
So 68. Did you throw a finger sign up at me?
cross my fingers, hopefully.
That's an ugly cross.
Let's cross my fingers.
That's an ugly
On my
cross.
video, cross my fingers. Hopefully.
That's so ugly. Do you follow the Do you follow the 68% rule type stuff with the z-scores, like at 68, 95, and 99.7?
That's not relevant for our purposes.
No,
What you're
that's
what you're
not.
essentially saying is,
That's what I said. I was just studying.
Learning
at those
too much.
inflection points, what she's saying is approximately 68.28% of the data falls between -1 and +1 standard deviation, because there's 34, oh sorry, that's a 2.6. 34.13. There. If you add those two areas together, then that's the 68.
But that's not.
And then there's a 95, give or take, a little
Uh-huh.
more, right?
But
When you
95.
go between two standard deviations,
And then it's 99.7 when you go 3.
yes.
I remember learning
But we
about
don't
this.
need to know that for
Not
this.
specifically. If that's necessary, you can pull it off the table based on where the z-score falls.
Okay.
Based on adding up above, below, between.
Okay. I feel like you just like this so much.
No, he does. That's why he teaches it.
You should bring us candy on days like this.
Girl.
We had candy in the last place.
You right? We did. Hey, go. You should go see in that classroom if they still have that
It's still
old
there, I'm
candy
sure.
in
I'm
there.
sure it's still there. I would be incredibly confident it's still there. At the
Well,
break,
you
I'll
should go
look.
get it.
That ball of candy? Isn't it old?
Chocolate
Shut
all
up.
that.
Oh, yeah, sure.
It's
Yeah, they were eating it last semester, so why not?
Right.
Oh my god, my stomach is growling over here for
Finish
real.
the test early, go get us something to eat.
Do you have any questions on the material for the exam?
I'm gonna go get something to drink.
Oh gosh.
Everybody got a Z-score table?
Yep.
You have a calculator.
4.
Everybody got the answer sheet.
I'm gonna make a point on hands out. So.
One question, are you gonna have the S formula when it has like, when we have to solve for the S first in one of them? You know what?
The S formulas are present on the formula page.
On the formula page. And sample is N minus 1, right?
Yes.
Yeah.
Okay. Finish reading.
And population is just.
And right here?
Is it fine if we have blank scrap
Sweating.
paper just in case we need lines?
Oh no.
It's fine. I got a new calculator that I stole from my school. So
We're gonna say like Walmart.
no.
I was like, really?
Miss Cam, where's my calculator? I don't know.
Oh.